Assalamualaikum warahmatullahi wabarakatuh. This video will be talking about the group assignment that will be tasked, which is the video assignment for CHM 260. So me as Muhammad Ali Faizal Rashid and also my group mate Muhammad Mu'alif Maimin bin Simsul, Siti Aisyah binti Azzatul Akmar, Nabiyah binti Muhammad Nizam dan Nur Hasanah binti Hasan. At the start of the introduction, we will be talking about the title of the experiment that we use. So first, is the determination of vanillin and ethyl vanillin in milk powder by headspace solid phase microextraction coupled with gas chromatography mass spectrometry. And the second title is simultaneous analysis glycol and vanillin in vanilla extract by using high performance liquid chromatography with electrochemical detection. And now we'll be talking about the principle and concept of instrument of gas chromatography. So principle first is a sample is being injected, either inter or injected and evaporated into the chromatography, and then the sample is transported through the column by the flow of inert gases mobile phase. And lastly, as the sample passes through the column, they are separated and detected electronically by detector. So concept of gas chromatography. So first, gas chromatography mass spectrometry that we use is an analytical method that combines the feature of gas chromatography and also mass spectrometry to identify different substances within a test sample. And also we use solid phase micro extraction, which is a relative new sample preparation technique that can reduce the amount of manpower required per sample and also increase the reproducibility.
Hi and Assalamualaikum, my name is Nabiyah binti Muhammad Nizam and I'm going to be explaining the methodology of gas chromatography. Let's start with the reagent and materials. In this experiment, we need natrium chloride that was baked under 400 degrees Celsius for 2 hours, then cooled to ambient temperature in a desiccator, acetonitrile, deionized water, standard vanillin, ethyl vanillin with purified greater than or equal to 99%, SPME devices which include 100, 30 and 7 micrometer polydimethyl silane coated fiber or PDMS, 65 micrometer divinyl benzene, 85 micrometer polyacrylate, 85 micrometer carbomolecular sieve, and lastly 30 micrometer divinyl benzene. So for the sample preparation, 1 gram of milk powder and 2 gram of natrium chloride were mixed with 5 ml deionized water in a 20 ml headspace bottle. Second, the solution was mixed by a MS3 basic turbine mixer for 3 minutes. For the standards preparation, to prepare the vanillin and ethyl vanillin standard stock solution, 0.05 gram of the standard substance was dissolved in acetonitrile to make a final 100 ml solution respectively. Second, to prepare the vanillin and ethyl vanillin intermediate solution, 10 ml standard stock solution was diluted with acetonitrile to make 100 ml respectively. To prepare a series of matrix mixture standard working solutions, the standard intermediate mixture solutions were progressively diluted with a blank milk powder matrix. The solution should be prepared freshly the day of the analysis. And lastly, standard curves were plotted with peak area versus analyte concentration after measurement under instrument working condition. Gas chromatograph analysis. Gas chromatograph coupled with mass spectrometer with EI source and CTC 3-in-1 auto sampler was applied to quantify the contents of vanillin and ethyl vanillin. The sample was incubated at 80 degrees Celsius for 40 minutes with a rotation rate at 500 revolutions per minute. After incubation, a 65 micrometer PDMS fiber was exposed to the headspace of the heated vial for 40 minutes. The fiber was then dissolved in the injection port for 5 minutes. Ultra pure helium passed through a gas chromatograph filter and was used as a carrier gas at a flow rate of 1 ml per minute. The injection column was used for separation. The initial oven temperature was set at 80 degrees Celsius with an initial 2-minute holding, followed by a programmed temperature ramp of 15 degrees Celsius per minute to 280 degrees Celsius and was held at 280 degrees Celsius for 2 minutes. The interface temperature was set at 275 degrees Celsius. The solvent delay was 5 minutes. The chromatograms of the samples and the mass spectra of vanillin and ethyl vanillin are shown. Under the above chromatographic condition, the baseline totally disunited between the peak of vanillin, which is 9.647 minutes, and ethyl vanillin, which is 9.973 minutes.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Alif Muhammad bin Shamsul, and now I will be present about result and discussion for GC. So there are three graphs here. Graph A shows the MSSIM chromatogram of vanillin and ethyl vanillin detected from the milk powder samples. As you can see from the graph A, vanillin, which is the peak 1, has the shorter time compared to ethyl vanillin, which is the peak 2. And the retention time of vanillin is 9.647 T per minute, while ethyl vanillin is 9.973 T per minute. For the graph B, shows that the mass spectra of vanillin. So the mass to ion change ratio of the vanillin is the maximum at 151.0 m per Z, while for the graph C is show the mass spectra of ethyl vanillin. So the mass to ion change ratio of ethyl vanillin is the maximum at 137.0 m per Z. So next I will talk about precision and recovery. So table 1 shows the precision and recovery of vanillin and ethyl vanillin detected using method N6. So standard vanillin concentration of 0.1, 0.2 and 1.0 mg/kg, as well as standard ethyl vanillin concentration of 0.05, 0.2 and 1.0 mg/kg was spiked into 6 milk powder samples, which is 1 gram per each, that were devoid of vanillin and ethyl vanillin. The spike samples were examined after being pre-treated using the sample preparation technique. Quantified amount of vanillin and ethyl vanillin in spiked milk powder were used to compute the recovery percentage. So this table 1 summarized all the findings. Vanillin spike recovery varied from 90.0 to 99.0% in the samples, whereas ethyl vanillin spike recovery ranged from 97.5 to 100%. Their respective relative standard deviation is for vanillin 2.3 until 4.1%, and for ethyl vanillin 1.9 until 5.1%. Now we move on to sample analysis. So table 2 shows the analysis result of vanillin and ethyl vanillin in milk powder. The amount of vanillin and ethyl vanillin in commercial milk powder samples were determined using the calibration plot technique, which the result are 0.1, 0.25, 0.51 and 2 mg per kilogram for vanillin, and 0.05, 0.25, 0.51 and 2 mg per kg for ethyl vanillin. The total number of samples was 50, with 30 being baby milk powder for babies age 0 until 6, and 20 being follow-on formula for babies aged 6 months or older. And that's all from me. Thank you. Now we move on to the next presenter.
Assalamualaikum and Hi, my name is Nur Hasanah binti Hassan, and I'm going to explain about the conclusion. In conclusion, the spike recovery of the sample range from 90 to 100%, and the relative standard deviation RSD range from 1.9 to 5.1%. The LOD is 0.1 and 0.05 mg/kg. Next, vanillin and ethyl vanillin has good linearity within the range of 0.1 to 2 mg/kg and 0.05 to 2 mg/kg. The calibration coefficients are 0.9992 for vanillin and 0.9991 for ethyl vanillin. Then, the qualitative analysis in this experiment is to detect coumarin, vanillin, and ethyl vanillin in vanilla product samples to determine the type of vanilla product at the end of the experiment. Lastly, the advantages of gas chromatography are high analytical efficiency, convenient operational process, wide linear range, good accuracy, and good precision.
And then for the last introduction, which is high performance liquid chromatography for the principle and concept. So for the principle first, it begins by injecting the solute onto the top of the column, and then separation occur as the analyte and mobile phase are pumped through the column, and then each component elutes from the column as speed on the recorder. And lastly, the response of detector to each component is displayed and known as chromatogram. So the concept of the instrument is first, high performance liquid chromatography utilize a liquid mobile phase to separate the component of a mixture. And then for the experiment is glycol and vanillin. It was analyzed as the important component in vanilla extract by new high-performance liquid chromatography.
Next, the methodology of high-performance liquid chromatography. So for materials, we need whole Madagascar cured vanilla beans or vanilla pennifolia with a reddish chocolate brown color and a moisture content of 25%. Next, short split Madagascar cured vanilla beans that has been cut with a substandard aroma, color and a moisture content of 11%. For the chemicals, we need acetonitrile, EDTA disodium salt, guaiacol, and sodium perchlorate monohydrate, ethanol, vanillin, and lastly acetonitrile. For the sample preparation and quantitative analysis of the vanilla extract, firstly, 20 grams of vanilla beans were cut into 1 cm pieces by knife and extracted with 100 grams of ethanol and water at 60 degrees Celsius for 4 hours to effectively extract the vanillin and guaiacol. The extract samples were filtered to remove the beans, diluted 2000 times with ethanol and water to minimize the influence of soluble solids in the vanilla extract, and subjected to a quantitative analysis by the Hplc method described next. So for the Hplc analysis, the Hplc analysis was performed with a Prominence LC high-performance liquid chromatographic system operated in the DC amperometric mode with a diamond working electrode and a silver chloride reference electrode. The potential of the working electrode was set at 1000 MV. A column was used for separation, and the mobile phase consisted of 100 mm sodium perchlorate monohydrate in water, 0.2 millimole EDTA in water, and acetonitrile for isocratic elution at a flow rate of 0.3 ml per minute and 40 degrees Celsius. And lastly, the injection volume for each sample was 10 ml.
Hi, Assalamualaikum. My name is Akmar, and today I am going to talk about the result and discussion for Hplc. These are the results of linearity, limit of reduction, and limit of quantification. The linearity of the system was checked by plotting calibration curve for the following 5 working standard solutions at 3 different concentrations. The respective calibration curve for guaiacol and vanillin were linear, where it indicates a respective correlation coefficients. It was represented by the regression equation as stated, where Y is the peak area of the analyte, X is the concentration of the analyte, and R squared is the correlation coefficient. With good specificity and sensitivity, Hplc easily detected both vanillin and guaiacol and quantification at relatively low concentrations. This allowed the target chemicals to be quantified selectively without interference from soluble solids in the vanilla extract. This is the precision outcome for guaiacol and vanillin. The percentage relative standard deviation for intra and inter-day positions of retention time and peak area was relatively low, where it was below 2%. However, the percentage RSD at the lowest vanillin concentration was slightly higher, where it was between 3 and 4%.
In simultaneous analysis of glycol and vanillin in the vanilla extract by using Hplc, the average respective recovery of glycol and vanillin range from 97.1 to 100% and 98.5 to 100%. Next, the quantitative analysis of the vanilla extracts in this experiment are higher content of glycol as the negative phenolic component and lower content of vanillin as the positive component in the extraction of MV cuts. Therefore, Hplc can establish a simultaneous and convenient analysis of glycol and vanillin in vanilla extract. These are the reference used for the experiment.